Hey guys, very good evening everyone, and welcome to today's session by 360DigiTMG. So we have been talking about capital market analysis in our domain analytics series, and for the past few days we discussed a lot of different techniques that we can use when it comes to a capital market. We also discussed about the applications. We discussed about EDA. We discussed about project management methodology called as a risk penalty. So today, being the final day, we'll be discussing about MLP, that stands for multi-layer perceptron. We'll be discussing about it today. Introduction, why there is a need of multi-layer perceptron and what is the importance of MLP in capital market analysis. This is going to be our agenda. And of course, we'll be also seeing the hands-on for our MLP. So guys, multi-layer perceptron or MLP defines the most complex architecture of artificial neural network. It is substantially formed from multiple layers of the perceptron. TensorFlow, as we know, is a very popular deep learning framework that is released by and is, we have been using it a lot. So, multi-layer perceptron networks are used for supervised learning format. And it is a typical learning algorithm for MLP network, which is also called backpropagation algorithm. MLP is a feed-forward artificial neural network that generates a set of outputs from a set of inputs. And an NLP is categorized by, or you can say, rather, I would say not categorized, it would be characterized by several layers of input nodes connected as a directed graph between the input nodes, which are connected as a directed graph between the input and the output layers. So MLP uses backpropagation for training the network, and it is a deep learning method. So here, as you can see, multi-layer perceptron is a neural network that learns the relationship between linear and non-linear data. Understanding this network helps us to obtain the information about the underlying reasons in the advanced models of deep learning. And multi-layer perceptron is commonly used in simple linear regression problems. However, MLPs are not ideal for processing patterns with substantial or with sequential and multi-dimensional data. When we further talk about your multi-layer perceptron, as you know that it is a supplement of feed-forward neural network, and it consists of three layers. The first layer is your input layer. Another one is your output layer. And the third one is your hidden layer. When you talk about input layer, it receives the input signals to be processed. The required tasks such as your prediction and classification is processed by your output layer. An arbitrary number of hidden layers that are placed between the input and the output layer are the true computational engines of MLP. Similar to feed-forward network, in a MLP, a data flows in a forward direction from input to the output. The neurons in the MLP are trained with the backpropagation learning algorithm. Also, MLPs are designed to approximate any continuous function and can solve problems which are not linearly separable. Major, you can say, use cases of MLP are pattern classification, recognition, prediction, also approximation. MLPs are neural networks that work as a universal approximators. That is, they can approximate any continuous function. For instance, they can be used for SEE models. And MLPs are composed of neurons called as your perceptions. So before explaining, or rather, let us continue with this. So a multi-layered perceptron is one of the most common neural network models that is being used in the field of deep learning. And MLP is simpler than the complex models of today's era. However, the technique it introduced have paved the way for further advanced neural networks. So your MLP is used for various of tasks. When it comes to your capital market, it can be used for stock analysis, image recognition, spam detection, and election voting predictions. So MLPs are able to approximate also, I was telling you, and they can approximate any continuous function rather than only linear functions. How do they do that? They do so by combining several neurons, which are organized in at least 3 layers that I was telling you, that either it could be your input layer, which simply distributes your input features to the first hidden layer, or one or more hidden layers of the perceptron. The first hidden layer receives as inputs the features distributed by the input layer. The other hidden layer may receive as inputs the output of each perceptron for the previous layer, and the output layer of perceptron, which receives as inputs the output of each perceptron of the last hidden layer. The perceptrons that are used by MLPs frequently use other type of activation functions than the step function. And for the hidden layer neurons, sigmoid functions are frequently used. When you are using the sigmoid functions, it will lead to smooth transitions instead of hard line decision based boundaries as when using your step. The activating function or your activation function of the output layer neurons is typically sigmoid for classification problems and the identity function for regression problems. When we talk about MLP, when we talk about the learning of the MLP, it also consists in adjusting its perceptron rates so as to provide low error on the training data. Okay. And this is usually done using your backpropagation algorithm, which attempts to minimize the mean squared error. But this does not mean that we cannot use other algorithms. We can be using other algorithms as well. Various strategies also can be used to avoid the overfitting the training data, that is to avoid the creating the models that have poor predictive performance due to modeling random error or noise present in the training data. So avoiding overfitting frequently involves allowing a higher error on the training data. That the one that could be achieved by the model. So MLPs are, global approximators and can be trained to implement any non-linear input-output mapping. And in a subsequent testing phase, they prove their interpolation ability by generalizing even in the sparse data space region. When designing a neural network, especially deciding a fixed architecture or performance and computational complexity, consideration plays a very crucial role. And it has been proved mathematically that even one hidden layer MLP is able to approximate the mapping of any continuous function. So as it happens with all your neural networks, the dimension of the input vector dictates the number of the neurons in the input, while the number of classes to be learned dictates the number of neurons in the output layer. So the number of chosen hidden layers and the number of neurons in the each layer have to be empirically, determined. As a rule of thumb, the neurons in the hidden layers are chosen as a fraction of these input layers. However, there is a trade-off regarding the number of neurons. Too many produce overtraining. Too few affect, you can say, generalization capability. So usually after satisfactory learning is achieved, the neurons number can be gradually reduced. Then subsequent retraining of reduced size network exhibits much better performance than the initial training of the more complex network. And a great care, guys, should be taken while, selecting the training data set. It has to be representative of all the data classes to allow a good generalization. During training, the input vectors are presented in a random order so that the network achieves a global learning and not class selective learning. MLP is another artificial neural network process containing a number of layers. In a single perceptron, distinctly, linear problems can be solved, but it is not the same case, or you can say it is not well suited for non-linear cases. To solve these complex problems, MLPs are considered. So MLP, as I was telling you, it is a feed-forward neural network combined with multiple layers, and generally it is used in the cases of different machine learning purposes. And the weights of the network over here are set in the random order before starting the training. After completing the training step by using your training data, the model is validated. In the training data set, say data x1 and x2 are the input and y is the corresponding expected output of the data. The output is, so suppose y is equal to w of x plus b. So in the training data set, say x1 and x2 are the input and y is the corresponding output. The output is dependent on the neurons and the weight of the neural network. So this could be represented in this manner also, where W is the weight and B is the bias. The weighted vector and the inclination vector of the main layer creates the weighted network and is referred as the inclination vector of the uh, nonlinear component. And the yield is associated with the contribution of different neurons in the shrouded layer and is noticeable in the yield. The yield assigns as 0, and 0 indicates whether a person, say, whether a buyer is going to trade for the stock or no. If it is 0, then no, and if it is 1, then he is going to trade that stock. Right? Moving ahead. So these were the layers that we were discussing. Multi-layer perceptron is a supplement of feed-forward neural network. It consists of 3 layers. One is your input layer, output layer, and you are having hidden layer. The input layer receives the signal to be processed. The required tasks such as prediction and classification is performed by a output layer. An arbitrary number of hidden layers are placed in between the input layer and the output layer. And these are two computational engines of the MLP, these hidden layers. When we talk about your use of the MLP in the capital market, so what we have observed is that in recent years, many attempts have been made to predict the behavior of the bond, currencies, stocks, or stock markets. So the multi-layer perceptron architecture are used to predict the incline, decline, or steadiness of an index. And index is nothing but measures the price performance. So results show that MLP networks can be trained to perform better than the index. With multi-layer perceptron, we can take trade decisions, right? And seeking the non-linear relationship between the stock market data and providing the corresponding basis for the investors to invest in the stock market. Price forecasting is also possible in stock market, which is a hot topic nowadays. So n number of things you can do when it comes to your capital market analysis by using your multi-layer perceptron. Some advantages. When we deal with your MLP model can be used to solve complex non-linear problems. It works extremely well with both small and large input data, whereas it is also helping us to obtain quick predictions after the training. Also, it helps us to get the same accuracy ratio with large as well as the small data. But with the disadvantages, there are some disadvantages also that are associated with your MLP. When it comes to the computation, with MLP, computations are a bit difficult and time consuming. It is also difficult to predict how much the dependent variable is affecting your independent variable. And the model functioning depends on the quality of the training data. That is why I said that when you are dealing with MLP or when you are working with MLP, you should take utmost care while selecting your training data set. Utmost care. So the model function is solely depending upon the quality of your training data, right? So what all things we understood till now? We understood that multi-layer perceptron is a fully connected class of feed-forward artificial neural network. And sometimes it means that any feed-forward ANN, sometimes it refers to networks composed of multiple layers of perceptron. Yeah? And it consists of three layers: the input layer, the output layer, and the hidden layer. A multi-layer perceptron having these layers along with many neurons that are stacked together. And while the perceptron while in the perceptron, the neurons must have an activation function that imposes a threshold like ReLU or sigmoid. Neurons in the multi-layer perceptron can use any arbitrary function. We also learned that NLPs are suitable for classification prediction problems where inputs are assigned a class or label. They are suitable for regression prediction problems where a real value quantity is predicted given a set of inputs. MLPs are neural networks which at least has three layers. While when we talk about deep learning in neural networks, these are additional or deeper layers, and deep neural networks and MLPs are both capable of performing such complex tasks as compared to traditional machine learning languages. So MLP has one input layer, and for each input there is one neuron. It has one output layer, and with a signal loop for each output, it can have number of hidden layers, and each hidden layer can have number of nodes as well. Another question that comes is that is MLP faster than your convolutional neural network? See, it is clearly evident that CNN converges faster than the MLP model in terms of epochs, but each epoch in CNN model takes more time compared to MLP model, as the number of parameters is more in the CNN model than in your MLP model. All right. When we compare your, MLP with RNN, since RNN is using more information than MLP, so theoretically the performance should be better than your MLP, right? And MLP is a fully connected, you can say, hierarchical neural network for CPU, memory, bandwidth, and response time estimation. Another thing is your MLP classifier. MLP classifier is, you can say, or a multi-layer perceptron classifier, which in the name itself connects to the neural network. Unlike other classification algorithms such as, support vector or naive-based classifier, MLP classifier relies on underlying neural network to perform the task of your classification. So, concluding these, we can say that MLPs are designed to approximate any continuous function and can solve problems which are not linearly separated. The major use case of MLP are pattern classification, recognition, prediction, and approximation. So we can conclude that multi-layer perceptron and some other advanced concepts based on the neural network putting efforts to predict and forecast in the stock exchange area or in trading or in banking, so on and so forth. Various, capital market use cases we can implement your MLP. Okay, so that was all. Let us So now quickly go to our Jupyter notebook. So here, what we are doing is we are using the multi-layer perceptron to recognize that will grow, that a stock will grow in a value after being trained on a set of financial indicators, like those that can be found in 10,000 fillings and so on and so forth. So here I have started by importing the required library and NumPy pandas I'm using for manipulating data. Pandas and data reader I'm using to pull the historical data using Yahoo Finance, sklearn and XCB for every machine learning related things. I've imported the required libraries over here. So as we can see that we need a function that allows to pull the historical price data for a given symbol. So we will this will be used to compute the return on investment of S&P 500 index and Dow Jones index. So I've loaded the data set over here. And when I'm loading it, I'm storing it in a variable called as PVAR. When I say PVAR dot head, these are the top 5 observations that I'm. When I'm saying data dot head, these are the top 5 observations I'm getting. I'm loading the 2 data sets over here. I'm checking for the missing values over here. I'm saying data dot is NA dot and I'm looking for the duplicated value also. So now once the data is splitted, we must split it into training data and testing data. So 20% of the data will be used to test the machine learning model. The parameter stratify is used in order to keep the same class ratios between training and testing distance. And from the train underscore split and test underscore split, we extract both input data as X train and X test, output data as Y train and Y test. And then we perform a check on that. So dividing the data by using your training and testing splitting. So here I have it. Now I'm printing those numbers and total number of samples I have 638. Total number of samples. Number of training samples I have 510. Number of testing samples I have your 120 and number of features I am having 107. Okay. So now we are doing the data standardization. And in this, what we are doing is we leverage the standard scalar available from scikit underscore learn. And it is important to use the same coefficient when standardizing both training and testing data. For this reason, what we are doing is we are first fitting the scalar to the input training data and then applying it to both input training and output input testing data. We are using the dot fit underscore transform method over here. So this is what I have done. And here I'm fitting it. And then I'm saying using this method, the values that you get after transforming the data, running this algorithm, store it into X underscore train. The same I'm doing for your testing. Now, what I'm doing is I am using your multi-layer perceptron model. The classification model over here will run and grid search CV is performed in order to tune some hyperparameters. That is, we are dealing with the hidden layers that I was telling you. We are dealing with the activation and solvers. The required number of cross validation is given as 5. And what we aim to do over here is we aim to achieve maximum weighted precision. So these are the tuned parameters that I have given. And I am, initializing the parameter grid over here to be tuned. Various parameters are given. Then I'm using your grid search CV also over here. So when we talk about grid search CV, grid search CV, as I was telling you, that it is a process of performing hyperparameters tuning in order to determine the optimal value for a given model. And the performance of a model, you can say, it significantly depends upon the value of the hyperparameter. When you talk about prediction, it requires the use of the parameter, and that parameter is a grid search CV. So here I have used it, grid search CV. I have used your MLP classifier, random state is equal to 1, batch size I have taken 4. Early stopping I have given as 2. Tune parameters, number of jobs, n underscore jobs I have given 4. The scoring is equal to precision weight. And total CV that I have taken is 5 over here. That is a cross validation. I am using this CL4 the model, and input training and output training data, and then I'm using your research CV value. The estimator I have given is that MLP classifier batch size 4, early stopping I have given as 2, so on and so forth. Then I'm trying to print the best score in the parameters found on the development set. Best score in the parameters that are found on the development set is 0.3 for activation, RELU, hidden layers, so on and so forth. I'm also trying to get the price variations for the stocks only in your testing split data that I have got. So for that, I have said evar.loc test underscore split dot index dot length. I've taken all rows and all columns over here. The value that we are getting, I'm storing it into a variable called as pvar underscore test. Now we are trying to build a data frame called as PF1, in which for each tested stock that is, we have been doing, and it is reminded that, what two classes are. 0, when we have 0, it means no. When we have 1, means yes. So here in this particular case, if we are having 0, means the person or trader is going to ignore that score, that stock, or when we are having 1, it means that the particular trader is going to buy the stock. So if the model predicts class 1, we proceed to buy your $100 worth of that stock. Otherwise, we are going to ignore the stock. So here I have given as buy amount is equal to 100, and DF1 is equal to PD.data frame. I've taken your output testing data, index I've taken text or test underscore split, so on and so forth. And for the DF1, I'm taking MLB. I am using your CL4.predict for testing data, input testing data. The values I am getting is storing into DF1 MLP column, and so on and so forth. Here I am taking your DF1 MLP that I got over here, and I'm multiplying it with the buy amount, storing it into a variable called as value start MLP, which is existing into a DF1, so on and so forth. Various things I have there. And when after doing this, what we finally observe when I say DF1.head is, for the various stocks, we are seeing the MLP value. So what it shows, or what we defined till now, that if we are getting 0, means we are going to ignore that stock. And if we are getting 1, we are going to buy that stock. So for the top 5 stocks, we are getting 0, we had 0, 0, 1, 1, 1 as our actual value. MLP value is saying 1, 1, 1, 1, 1. So we are going to proceed buying these stocks for $100. that is zero. So that is how we do the prediction using your MLP or classification using your MLP when it comes to the stock trading. So finally, what we did is we build a model, compact data frame model underscore comparison, in which we collected the main information over here that is required to perform the comparison between the classification model and the benchmark. Leveraging the data frame DF1, we can easily compute gains and losses for each model, that is net gain and percent gain. Since we missed the data from the benchmarks, we quickly exploit the custom function get underscore price underscore var in order to get the percent price variation for both S&P 500 for the year 2019 and 2019 percent price variation for the technology centers computing by using dot. We are taking the average of that on the whole column of your dataset PBEF. So this is what I have done over here, and this is the final compact data frame that we have built. You can see the accuracy. You can see the F1 score. You can see the support value for ignoring, what is the precision, for buying, what is the precision, what is the recall value. All this information you can see over here. So this is how we continue using your MLP into our stock market analysis. Another thing is, why is it basically required? Or why a multi-layer neural network is required? Basically, by adding more hidden layers, more neurons per layer, you add more parameter to the model. Hence, what you are doing is you are allowing the model to fit more complex functions over there. So guys, a quick recap of what we have done till now. So we talked about MLP, and MLP is nothing but it is a supplement of feed forward neural network. And as we talked about, it is consisting of 3 layers: the input layer, the output layer, and the hidden layer. The input layer is receiving the input signals to be processed, whereas the output layer tasks, the required tasks such as prediction and classification is performed by your output layer. And an arbitrary number of hidden layers that are placed between the input and the output layer are the true computational engine of your ML. That is what we discussed. We also discussed that, it is a fully connected hierarchical neural network. When we talk about your MLP, it contains one or more hidden layers. While a single layer perceptron we are talking about what is single layer and what is multi-layer perceptron. A single layer perceptron can only learn linear function. A multi-layer perceptron can also learn your non-linear functions as so single and multi-layer. When we talk about single layer perceptron, it can only learn linear functions, whereas multi-layer perceptron, it can learn non-linear functions as well. So guys, that was all about our multi-layer perceptron. Hope this session would have been enlightening to you all. So thank you so much for joining. It was a wonderful session. It was a wonderful experience taking this session for you guys. Keep on learning, keep on practicing, be safe. Thank you so much. Have a good day.